Hi, welcome to our pre-calculus. Topic today is finding solutions in an interval for a trigonometric equation involving sine and or cosine using double angle identities. So the double angle identities for cosine and sine, I have listed them here. We had these things covered a while back, and now we are looking at some equation that has either sine of 2x in it or cosine of 2x in it, and the question is, how do we handle it? Of course, cosine in the other one is also cosine, so perhaps that looks like good news, but then the arguments are different. This is x, that is 2x. We have to use double angle identities to convert them all to the same base, if you wish. All of them have to be based on x. So here, given that this portion is cosine, what equation, what identity is best for me to use? Well, do we have choices? Of course we do. For cosine, we have three choices of cosine of 2x. The ones that get to be used would be one of these two, because we are always worried about having just one base function. Since I have cosine here, I'm going to go ahead and use this one. So everything stays in terms of cosine, as opposed to creating problems for myself and having injection of sine into our problem. So for this cosine, I will write 2 cosine square of x minus 1. Okay, so this all sitting for cosine of 2x. Then minus cosine of x, that's the second piece, is equal to minus 1. Now what happens? Well, the minus 1s cancel, and I have 2 cosine square of x minus cosine of x equal to 0. Factor a cosine, I have a cosine times 2 cosine of x minus 1. You remember a long time ago we did this thing by substitution. A, for example, for cosine of x and so on. By now I hope that you can just factor as it is without needing the substitution. However, if you do want to do the substitution, that's perfectly fine. You can just proceed based on that. So we have two factors, product is 0. Either of them could have been 0. We investigate these two possibilities. The first one tells me x cosine being 0 in interval from 0 to 2 pi. I have these two possibilities, and if I wanted to go further, I would have added 2k pi to these things. The other one gives me cosine of x is equal to 1/2, and for that I get x is equal to pi third, and then 2 pi minus pi third, which is 5 pi third. These two possibilities are there. So final answer is a combination of all of them. Pi over 2, 3 pi over 2, pi over 3, and 5 pi over 3, comma separated list of possibilities. And we want in radians, more than one separate with comma, and use the palette that you have there to enter pi. Similar question here. Now this term is just sine, so what's a good idea to apply here? Cosine of 2x, we want all of our functions to be the same, so I use 1 minus 2 sine square of x. Okay, that was another form of the identity that we had. It was this style. Why do we use that? Because we want everything to stay same base function. So minus 2 sine of x plus 1 minus 2 sine square of x is equal to 1. Ones cancel out. I can factor minus 2 sine of x from whatever is left. Okay, minus 2 sine x can be factored. We are left with 1 from here and sine of x from there, equal to 0. This gives us sine of x equal to 0, or sine of x is equal to minus 1. Sine is 0 at 0 and pi. and sine is minus 1 at x equal to 3 pi over 2. So that's it. Another version of this, now this time we have sine of 2x. Sine of 2x, the identity for that was 2 sine x cosine of x. So we take it, sine of 2x is 2 sine of x cosine of x. So we have 2 sine x cosine x plus another 2 cosine x, that's the second piece, equal to 0. Factor 2 cosine x. We are left with sine x plus 1 equal to 0. So two possibilities, either cosine is 0 or sine x is equal to minus 1. When is it that cosine is 0? At pi half and 3 pi over 2. When is it that sine is minus 1? That's again another 3 pi over 2. So these are the same thing, and probably your software will be happy if you just report one of them. Further up in mathematics, how many times a certain root shows up is an important consideration in its own right. It's called multiplicity. Just same way that if you have two identical kids, you don't say I have one kid just because they look like each other. In mathematics also, if the same root shows up multiple times, it is significant, and there are ways of flagging it, but I don't suppose our software is flagging anything here. So we just list pi over 2 and 3 pi over 2 and call it a day. Okay, so what we learned here, double angle identities, we have use for this form. Sorry, the screen jumps. We have use for these two forms. For cosine of 2x, for sine of 2x is just one form anyway. The idea is always to try to reduce how many functions show up in our equation. So when we are doing this one, cosine of 2x, we use this formula so that we stay within cosine. If the other term was sine, we would have used this one. For sine of 2x, we don't have a choice. It's always a mix. So after substitution, we always hope for a straightforward factorization. Okay, until next time, good luck and God bless.